Lesson 3.7, we're talking about transformations. You know, that transformation chart that we had in lesson 1, we had in, or topic 1, topic 2. Well, here we are again. I don't think I put on your formula page, but it's been on the last 2 formula pages. Okay, how we move left, right, up, down, stretches, compressions, reflections, all of that. Okay, now, and we'll talk about that more on the backside of notes, so probably Monday. But what we're going to start talking about today are even and odd functions. Okay, a function can be something called even. If it is even, there's your key. If a function is what we call even, it is symmetric about the y-axis. What do we mean symmetric about the y-axis? Take the y-axis, fold it in half there, and it's the same. Yes? Go back to your elementary definition of symmetric. Now, that's the easy route. If you have the graph, you can easily see. The algebraic route is that f of x equals f of negative x. That's probably the trickiest thing we're going to talk about today. We'll work on that. Okay, we'll work on that here in a moment. But that's the algebraic. Now, an odd function. There you guys go.
Could all ecology students going on the field trip today report to the middle school doors? Ecology field trip to the middle school doors. Thank you.
Have fun, guys. Okay, an odd function is symmetric about the origin. Okay, now, this one's not quite as easy to look at, but you'll get the idea. So, symmetric about the origin. This is our example here. It looks like an x cubed graph. One thing, symmetric about the origin, you could think of it being a 180-degree rotation. Okay, so if I take that and I am able to rotate it upside down, okay, the graph looks the same. That's one way to look at it. I put it in terms of reflections. In that, okay, if you just think about this as a quadrant, if I take first quadrant and I reflect it across both axes, doesn't matter which you do first. So like if I take it and I reflect it across, say, the x-axis, now it looks something like that, right? If I take that and I reflect it across the y-axis, it lands on there, doesn't it? Okay, so that's the way I kind of look at it is you can reflect it, like take just a quadrant, separate a quadrant out, you can reflect it across both axes, and it lands on top of itself. Okay, that's what symmetric about the origin is. We'll also have an algebraic definition. F of negative x equals negative f of x. Again, we'll go through that. Now, your third option, a function can be even, it can be odd, it can be neither. Neither, basically, it doesn't fit into either of the first 2 categories. Okay? It's not symmetric about the y-axis, it's not symmetric about the origin. Or the 2 algebraic statements are not true. Okay, so neither is, you don't know neither until you test the other 2. If it fails the other 2, falls into the neither category. Okay, this is an example here where, in all honesty, if this was centered differently, like if this right here was the origin, this would actually be an odd function. But because it's not centered at the origin right here, because it is off-center, it falls into neither category. Okay? Okay. Now, we're going to start with the graphs. We're going to start with the easy part. Okay? So, symmetric about the y-axis, symmetric about the origin, or neither category. So as we look at A, classify the polynomial functions as, I guess in my directions I said even or odd, but realize there's always the neither option. Okay? So, as we look at graph A, is that symmetric across the y-axis, so thus even? Is it symmetric across the origin and thus odd? Or is it neither of those categories and it's just neither? What do you think? Huh? I could agree with odd. And here's what I'm going to say. Okay, can we definitely rule out even? This is not a fold it across the y-axis and it lands on top of each other, is it? So it's definitely not even. That one's knocked out. Odd, here's what I'm going to look at, okay? One, I could rotate it 180 degrees upside down, and it's the same graph, isn't it? And I can't do this with the BenQ, but can you take your paper and turn it upside down? Does it look the same? Okay, does my paper right here look the same as that graph up there? It does. Okay. So, and then also, as I said, I like to just, okay, take like, for instance, this piece right here. Well, if I reflect it across, say, the Y, it ends up over there. Then if I take this same piece and reflect it down here, it ends up on top of that, right? Okay, so that's another way I look at it. One way or another, I need you to come up with the fact that this graph is odd. And it doesn't say a reason, but I'm putting that it is symmetric. I just put symmetric origin, but symmetric to the origin. Okay? Okay. Get what you need there. Then think about B. We have a different graph on B. Is it even? Is it odd? Is it neither? What are we thinking? Don't overthink it. What do we think? Is it even? Is this symmetric across the y-axis? Yeah. I can fold this graph here at the y-axis and it's going to land on top of itself, yes? So this is even. Okay? It is symmetric to the y-axis. Okay. What about C? Go through the list. Is it even? Is it symmetric about the y-axis? Is it odd? Is it symmetric about the origin? And then if it fails both of those, is it neither? What do we think here? Is it even? It's not even, right? I can't fold it in half across the y. Is it odd? Lane, I'm going to pick on you. I saw you shake your head no. Why'd you say no?
Because
I like your answer. I do like your answer, but why?
doesn't pass both ways.
Okay.
Go through.
Okay, you just know.
Yeah.
I get it. It's sometimes hard to explain. What's the catch here, guys? Why is this not odd? If this was odd, this could be odd if what? If that was at 0, 0, would this be odd? Right. But is it at 0, 0? No. I saw Morgan turning her paper upside down and comparing it to the BenQ. Okay? Okay, let's do that. If I turn my paper upside down, it now crosses through -1. My graph here crossed through +1. Is it the same? No. Okay, are those some examples for you? Okay, so this is a neither. Okay? Am I making sense? And this is where they try and trick you. It's like, oh, it looks like it could be odd, but it has to be at that centered at the origin. Okay? That's the key. If that was centered at the origin, that would be the different answer. Okay? Okay. What about D? Even, odd, neither. Odd? Is this one centered at the origin? Yeah, if I spin that around the origin, it's going to be the same. Okay? I guess I didn't leave myself room at the bottom to write, did I? So I'll put it over here. This is odd. And this is symmetric about the origin. What about E? Even, odd, neither. Huh? Even? Is it symmetric across the y-axis? Can I fold that y-axis in half? I can. So this is indeed even. So symmetric about the y-axis. Okay? You got the feel for the graphs. The graphs aren't bad, just don't let them trick you. Okay, that's the hardest part, is they try and trick you, but don't let them trick you. The graphs aren't bad here. Okay? Okay. Well, now we've got to do what I think of as the more difficult part, is when you don't have a graph to look at and you just have the equations to look at. Okay? Now, I could say, well, put it into Desmos and look what Desmos says, but do you have the Desmos option on a test? No. Okay, so we need a plan B. Now, if you go back up top, for even, it says f of x equals f of negative x. And for odd, it says f of negative x equals negative f of x. Those are the two statements we're going to try and either prove or disprove. Now, we know f of x here, yes? So I always start by testing even. And the question there is, does f of x equal f of negative x? So that means I need to start off trying to find f of negative x. To find f of negative x, every place we see n x, I'm going to replace it with negative x. So 4 times x to the fourth. So I'm going to write that as 4 times, parentheses, negative x to the fourth plus 5. Now, here's what you need to know. A negative raised to the fourth power. What do we know about a negative raised to the fourth power? A negative raised to any even power becomes a positive. So this is positive x to the fourth times 4, which makes it 4x to the fourth plus 5. What did I just show? F of x was 4x to the fourth plus 5. F of negative x is 4x to the fourth plus 5. If you look up above, if f of x equals f of negative x, which is the statement we just showed is true, then we know this is an example of an even graph. Okay? And once you know that it's even, you're done. Stop there. Okay? We're not going to find something that's going to be even and odd at the same time. It's even or odd or neither. We don't get a both category here. Okay? So there's an even example for you. Okay? Okay, let's try B. With B, I'm going to start the same process over again. I always test even first, no matter what I think is going to happen. Because here's the deal. Half of that even test, I'm going to need to do my odd test. So, they give me g of x. First thing I'm going to try and find is g of negative x. So, every place I see an x, I replace it with negative x. So 2 times negative x raised to the third plus 3 times negative x. Let's clean that up. What is a negative x raised to the third? So what is a negative raised to the third? That's a negative. So that's going to be negative x to the third times 2 makes this term negative 2x to the third. 3 times negative x makes that a negative 3x. You could say plus negative 3x, but I tend to just go straight to minus 3x. Okay. What do I know at this exact moment? It's not even, correct? And that's the first thing. Let's see, do I have room to? I just discovered that g of x does not equal g of negative x. So it is not even. Okay, that's what I know at this point. So if it fails the even test, guess what we do now? The odd test, right? So now, okay, look up top at your odd test. If it's odd, f of negative x, or in this case, g of negative x, well, didn't we just find g of negative x is supposed to equal negative f of x, or in this case, it'll be negative g of x. So what do I need to find? I need to find negative g of x. That's what I need to find to decide my final answer here. Now, negative g of x says you take whatever g of x is and you multiply the whole thing by a negative. So I'm going to write it as negative parentheses 2x cubed plus 3x. Now, you can go ahead and skip that if you want, because what am I going to do with that negative? We're going to distribute it. Every term gets multiplied by a negative. So basically, every sign gets changed. So negative g of x is negative 2x cubed minus 3x. Thoughts? What do we see here? Here is negative g of x as negative 2x cubed minus 3x. What are we testing to see if it's the same as? G of negative x. So is g of negative x the same as negative g of x? It is, isn't it? Okay, this right here is the same as this right here. So I just discovered that g of negative x equals negative g of x. And so according to my chart up top, that means that this is odd. Okay? So this is an odd function. Now, guess what? If it already failed the even test, if it failed the odd test, now where would we be at? We'd be at neither. Okay? So once it passes a test, you get to stop. But that's the process I take on these problems. Okay? And of course, I'm writing everything out. Obviously, some of this could be done in your head depending on how comfortable you are with it. But you're going to see me write everything out. Ready to try C? Okay. First of all, I'm going to find, does f of x equal f of negative x? So every place I see an x, replace it with negative. Goodness. 7 negative x raised to the 5th power minus 2 times negative x raised to the second power plus 4. Don't ask. I have no idea what my brain's doing this morning. Okay. So f of negative x. Okay, what is a negative x raised to the 5th? A negative raised to the 5th is going to be negative. So this is going to become negative 7x to the 5th. What is a negative x raised to the 2nd? That's going to be a positive x to the 2nd times the minus 2 that's already there. So this stays minus 2x to the 2nd plus 4. Okay, is it even? Slight difference here, yes? It's just one sign difference, but one sign difference is all it takes. We got positive 7 versus a negative 7. So what my brain is telling me right now is that f of x does not equal f of negative x, and so this is not even. Okay? And again, I'm writing all of my brain work out here, so. Okay, we failed even. If it's odd, f of negative x, which we already know, needs to equal negative f of x. So what do I need to do now? We need to find negative f of x. Remember, negative f of x says we take the whole thing, multiply by negative. So for my work step, I showed it as negative times the quantity, 7x to the fifth, minus 2x squared, plus 4. By all means, you're welcome to jump ahead on that, right? So negative f of x, change all the signs. Becomes negative 7x to the fifth, plus 2x squared, minus 4. Well, what just happened? It's not odd, is it? Does f of negative x right here equal negative f of x? It does not. Okay. So in this case, I'll go ahead and write it out as f of negative x does not equal negative f of x. So my brain says not odd. And if my brain says not even, not odd, then we are at, all that work gave us an answer of neither. Okay? So, even, your original equals f of negative x. Odd, the g of negative x equaled negative g of x. Neither, both of those failed. And I'm giving you one more to practice on. You've seen one of each, right? You know my teaching style. I'm going to show you an example of each if possible. Now, you don't know what answer this is at this point, right? You could have guessed the others ahead of time. Okay, f of x equals x to the 6 minus 2. What am I going to start finding? I want to start testing for even, so we need to find f of negative x. So every place I see an x, replace with negative. So negative x raised to the 6th minus 2. What is a negative raised to the 6th power? A negative raised to an even power becomes a positive. So this becomes positive x to the 6th minus 2. And what are your thoughts? F of x is the same as f of negative x. So, since f of x equals f of negative x, we know this is an example of an even graph. Okay? If you want the extra step of checking yourself, in homework, in review, after you do the algebra, could you put it in Desmos and see what the graph looks like? You could. Okay? Obviously, that doesn't help you on a test, but as you're trying to learn it and check yourself, that could be verification there. Okay? Okay, guys. I know the algebra part's not the fun part, but it's not. I'd still argue it's probably easier than what we've done the last couple of days, so. Okay, where am I at? Okay, well, we're going to go ahead and move on to the back a little bit and talk about the back. And that just won't leave us with as much to do on Monday, which I think could be good. Okay, so on the back, we are going to talk about transformations. Now, how well do you know your transformations at this stage of the game? Okay. Back in topic 1, you had a green paper that had your list of transformations on it. Back in topic 2, you had a blue paper that had the list of transformations on it. Now, in topic 3, so it was at the top of topic 2, or the original was back in topic 1, right? I didn't put it on topic 3 formula page, did I? I didn't think so. However, can you pull out topic 1 or 2 formula page? Always. Okay? I hope you pulled on to those. If not, guess what? You just saw me grab more. I have more, right? I keep extras for all year long because guess what you're going to need come final exam time? Those same formula pages. So, okay. So this is graphing transformations of cubic and quartic. This isn't a whole lot different than everything else we've done. We've already looked at transformations of quadratic, just when there was an x squared. We've looked at transformations of absolute value. This is just now, okay, cubic means there is an x cubed involved. Quartic, do you remember this one? It means there's an x fourth involved. That's all it means. Okay? How does the given graph differ from the graph of its parent function? Now, that means for what we're doing today, the parent function is either y equals x cubed or y equals x to the fourth. Okay? That's what that means. What are the transformations? Are we translating left, right, up, down? Are we reflecting across the x or y axis? Are we vertically stretching? Are we vertically compressing? Those are the pieces we're looking at. So thoughts on A. G of x equals 3x to the fourth minus 18. Thoughts on what any of those numbers mean? And up on the TV is the green paper. If you don't have your own that you want to refer to right now, or you just didn't get it out. Thoughts on what that 3 is doing? Where is that 3? No. Where is that 3? That 3 is where? It's right in front of the x, so it's right in front of the function. Okay, so it's like an a value here. 3 is bigger than 1, so it's a vertical stretch. Okay, what about that minus 18? Yeah, and the question is it a minus 18 like this minus c, or like the minus c in parentheses? Yeah, like the first one. It's not in with the x, right? It's not in the parentheses with the x. And so it is just a down. So this minus 18 represents that we're going to translate down. This 3 represents a vertical stretch. Now, obviously, I want words. The complete sentence is wonderful. Some of you guys get so short and choppy with this. Complete thoughts. Now, there's one other thing I want you to add in, okay, that we really focus on working on. What graph is this being done to? What is the original graph in this case? And that is what? X to the fourth. So in your description, I want you to include what we refer to as that parent function, the base function. So mine reads something along the lines of the function y equals x to the fourth has a vertical stretch by a factor of 4 and is translated down 18. So something including that x to the fourth. Okay. So I'm going to say the function y equals x to the fourth has a vertical stretch by factor of 3 and is translated, is the word I like to use, down 18 units. Okay? Obviously, key things to mention there. Y equals x to the fourth, vertical stretch, factor of 3, translated down, 18. Those are some key pieces. So like when I'm grading a test, I'm going to be looking for those pieces to give you full credit. Okay, B. Start thinking about what transformations you have there. You're fine. I thought you were Okay. What are your thoughts on B? It what? Okay, it has an A value. An A value, according to up top, is a vertical stretch or compression. What is 5? A stretch because it's bigger than 1. Yes? So that's a vertical stretch. What else do we know? Are there some C values according to our chart? What about a -2 in the parentheses? That's going to be a right 2. What about a +4 outside of the parentheses? Up. And what's my parent function? What graph is this being done to? Y equals x to the third. Okay? So, I'm going to say, I'm going to use the graph of y equals x to the third, same thing as same function, has a vertical stretch by factor of 5 and is not it. I'm going to use the word translated again. And it is translated right 2 and up 4 units. Okay? Again, not that your wording has to be the same, but did you include up 4, right 2, something like translated, vertical stretch, factor of 5, and did you include the parent function of y equals x cubed? Okay, let's get C in real quick, and that'll be a good finishing point. Okay. C, f of x equals 2x cubed minus 5. Okay. This is pretty basic, isn't it? If you ask me, this is a repeat of what we've done how many other times this year. So I'm hoping you guys see it as basic as I do. Maybe not, but okay. What's that 2? Vertical stretch. Why did I put all stretches in here? Weird. I don't know why I put all stretches in here, but I did. What about that minus 5? Down 5, because it's outside. It's not in with the x. It's not in a set of parentheses. So down 5. And what's my parent function? X to the third. So the graph y equals x to the third is vertically stretched by a factor of 2 and translated down 5 units. Okay? And again, key pieces. Your wording doesn't have to be the same as mine, but mention x to the third, mention a vertical stretch and that factor of 2, and mention the translate down 5. Or shift down 5, or move down 5. Put some verb in there, okay? Drives me crazy when you guys just say down 5. Give me a verb to go with that action, okay? Okay, Monday. We will write some equations based on transformations, and you'll have some work time, okay? If you're not cut up in sawdust, make it happen.